It's easy to think of our bodies as just parts. A heart, some lungs, a stomach. But what if we looked at it differently? What if it's actually a perfectly coordinated orchestra? Every single system, every cell, playing its part in this incredible symphony of life. So yeah, let's dive right into this amazing performance.
So, let's start with something we all do every day. How does a simple meal, say the sandwich you had for lunch, power your entire life? I mean, really think about it. That food somehow becomes the energy for you to think, to move, to even just exist. So, how does that actually happen? We're going to follow that journey, right from that first bite all the way down to the energy that's firing in your cells as you listen to this.
All right, first stop on our tour is what I like to call the body's main processing plant. We're talking about the digestive system. This is where all the raw materials, our food, get dropped off and completely broken down into something the rest of the body can actually use.
Seriously, this whole process is like a super efficient disassembly line. It kicks off right in your mouth. And by the time that food hits the stomach with all its powerful acids, trust me, it's a whole different substance. But here's the key part, the real star of the show, the small intestine. This is where your body gets super meticulous and pulls out all the good stuff, all those vital nutrients we need to survive. After that, well, the rest of the journey is pretty much just cleanup.
Okay, so we've done it. We've processed the food, and we've got this amazing usable fuel. But there's a huge problem. All that good stuff is just sitting there in one place. So our body has this massive logistics challenge on its hands. How in the world do we deliver these nutrients to trillions of cells all over the body that are all screaming for their share?
And the solution? It's an absolutely incredible distribution network. The body basically has these two major highways to get everything where it needs to go. You've got the bloodstream and you've got the lymphatic system. They each have a totally different job, but believe me, they are both absolutely critical.
So, if you picture the bloodstream as this massive superhighway, it makes perfect sense. It's the express lane, right? It's rushing oxygen and nutrients everywhere. And at the same time, it's the garbage truck, hauling away all the waste, like carbon dioxide. Now, the lymphatic system, that's more like a specialized service, a special delivery network. It handles the jobs the superhighway can't, like absorbing fats from your food, and, get this, it's a huge part of your immune system's defense force.
So when you actually look at what's in your blood, it's kind of mind-blowing. Over half of it, 55%, is just plasma. That's the liquid that carries everything around. Then, almost all of the rest, that big 44% chunk, is your red blood cells. Think of them as the oxygen couriers. And that tiny little 1% left over, that's your security detail, your defense force. We're talking white blood cells and platelets, the things that protect you from getting sick and stop you from bleeding.
Okay, picture this. The delivery trucks, our blood cells, have arrived. They've dropped off all the nutrients at every single cell. Awesome, but these are just raw materials. It's like having a pile of perfectly good firewood right next to a fireplace. It's totally useless until you have a spark to actually ignite it.
So what is that spark? What's the match that lights the fire? We've got the fuel delivered. Now, how do our cells actually turn it into real, usable energy?
And the answer, you've probably guessed it, is oxygen. And for that, we need to bring in the respiratory system. This system is what provides that constant, life-giving spark that our body needs to turn fuel into energy.
Yeah, this right here is pretty much the core of everything. Oxygen is the key. But how does the key get in the lock? Well, with every single breath you take, oxygen rushes into these millions of tiny little air sacs in your lungs, called the alveoli. And right there, it gets handed off to the red blood cells. They're like the delivery drivers for the spark, taking it to every cell so they can finally burn those nutrients and, power your entire life.
Okay, when you have a system this complex and this incredible, you absolutely need to protect it, right? So now let's talk about the body's security and maintenance crews. These are the systems that are always on standby to handle emergencies, fight off invaders, and just generally keep the whole operation running smoothly.
So, imagine you get a cut. Instantly, literally in a split second, this whole emergency protocol kicks into gear. Step 1, the blood vessel itself clamps down to slow the leak. Right after that, the platelets, think of them as the tiny first responders, swarm the site and form a quick temporary plug. But the real fix, the permanent seal, comes from this incredible chemical reaction that weaves a tough web-like clot to stop the bleeding for good. It's amazing.
And this whole idea of friend or foe is absolutely non-negotiable when it comes to something like a blood transfusion. Your blood type is basically the uniform your red blood cells wear.
If you introduce cells wearing the wrong uniform, your immune system's security guards will see them as invaders and attack. And that's exactly why O negative is called the universal donor. You can see it on the chart. Its cells are like stealth operators. They wear a generic uniform that doesn't set off any alarms.
So, with all this complex machinery running 24/7, how do we actually know if everything's working the way it should? How do we, check under the hood? Well, that's where diagnostics come into play. They give us that crucial status report on what's really going on inside.
Let's go back to the respiratory system for a second. If a doctor suspects there's an infection in your lungs, like pneumonia, they can do something called a sputum culture test. It's a way of identifying the exact bad guy. By analyzing the gunk from your lungs, they can pinpoint the specific bacteria or fungus causing all the trouble and then pick the perfect weapon, the right antibiotic, to fight it. It's a fantastic example of targeted diagnostics.
And hey, what about that emergency clotting system we were just talking about? Yep, you can test that too. There are all sorts of tests, like the prothrombin time or APTT, or even just a basic platelet count. And these tell doctors if your blood is clotting too slow or maybe even too fast. This is super important for finding bleeding disorders or for just making sure someone on blood thinners has the right dose. So as we bring this all together, it really comes back to that one big idea we started with. Digestion, circulation, breathing, defense, they're not separate shows. They are all completely interconnected, playing together in this constant, complex, collaborative symphony. And every single instrument has to play its part just right.
And that really leaves us with one final thought. This absolutely incredible performance, this symphony, is happening inside your body, right now, millions of times a day, and you don't even have to think about it. So the real question is, what can you do to support the musicians? How can you help take care of the orchestra?